Max, so we're going to switch from bonds to another topic. I don't know if you've heard of it, semiconductors. We are joined once again by Ben Pouladian on X at Ben ITOZ. And actually, we may need a second to get on, or do we, folks? Can we go live? I think okay, yeah. Sorry. Okay, Ben, I mean, since we did our interview, I don't know, Semi's up a decent chunk a few weeks ago, but what is going on with this chip called Etched? I'm going to pull it up, but just exactly what are we talking about here?
So Etched just came out of stealth today. They raised $800 million with a lot of big time investors, from social media influencers to Jake Paul to some really heavy duty VCs. And I guess the idea that the two folks out of their Harvard dropouts had is that instead of having like a general purpose GPU like what NVIDIA has that changes, why don't we take established models that are like pretty well established, like Llama or like a Mistral model, have it fixed, just basically etch or write all the instructions on this chip, and then run inference against that model. And if we do that, we cut off a lot of the extra stuff that comes with an NVIDIA GPU, and you can basically have faster inference, really fast.
Share the screen, please. Ben, yeah, go ahead. Yeah.
Does that make sense?
Go ahead. Yes, that does make sense.
So how much faster are we talking? And then is it cheaper to produce the chip?
I don't have the numbers, but obviously if you're using less stuff and less power of what they're saying, you're basically using like a smaller engine, then theoretically it will cost less to make and cost less to serve, because they're saying low voltage inference, and then they have clusters, but then there's a lot of wires. So there's a lot to be seen.
Yeah, can you share the screen here? Yeah, this is from the Etched team. They've got low voltage inference, so they're going to use less power. And then the next cheap, cluster scale memory for low latency workload. So they're not saying that they're going to use a ton of less high bandwidth memory, but they're kind of implying it. It's hard to. I ran this post through my LLM, and it kind of gave me a conflicting answer. And I think technically, the Etched chip uses more HBM, like 80% more than H200s, but it does use less than Blackwell and like way less than Rubin, so it technically does use less. So Ben, like obviously we're in a huge memory bull market. If the world is running on Etched instead of on NVIDIA for inference, I know this is kind of inference only, is that a world where there's less memory and power being consumed, or
no?
more?
I think this it's just demonstrating the fact that the whole GPU AI infrastructure market is maturing, and people are finding different ways to specialize within the stack. And this is just one aspect of it. It's like new companies are forming, and this is one of them. I mean, there's Positron, which almost does the same thing. There's obviously Cerebras, which just went public. There's Groq that NVIDIA absorbed. Everyone was trying to attack this the same sort of way, because if you have like a $5 trillion market cap or opportunity of what NVIDIA has, you just need to get a little slice of that and prove to those customers that you can deliver fast inference and speed to be able to do that. But the question is do you have in the developer ecosystem, do you have the whole manufacturing supply chain really set up at scale? I mean, you're really going against some big companies trying to challenge them on the rack scale. I think you'll find some really good solutions for Etched on like faster chatbots or coding assistants or very specialized tasks. But we have to really be cautious and see how this actually scales in the future, because it's one thing to have this, but to scale it and go through all the pain and suffering that companies like NVIDIA are now that went through, and now AMD is trying to actually get out with its first rack scale solution. There's a lot of variables and challenges that you need to go through to actually achieve that. It's not as easy as it sounds. It's very hard.
Ben, can you share your can you repost the actual stream, Max?
No, my question was about how much clarity we have on that. I'll play the skeptic here. We built our first racks after successful A0 tape out 1 billion in customer contracts. So 1 billion in customer contracts. I mean, how far out could those contracts be? And then they also went so far as to say they opened a Taiwan factory for 24/7 engineering. So, how many chips can they actually produce? If for a company like this, of this size, what is the scale?
I mean, at the end of the day, when you're doing a startup like this, for the most part in this segment, it's going to be hard for a lot of these specialized semiconductor companies to remain independent. So a company like Cerebras or Positron or even Etched will have the same fate as Groq. They'll probably get absorbed by one of the major companies, AMD, Intel, or someone else, because they're just specialized in one aspect. They're not going to have the scale and buying power that like a Broadcom or an AMD or an Intel or even NVIDIA has to really manage and run the supply chain. They'll make a dent. They'll make a lot of waves. You've seen it on social media, on X today. Everybody's reposting these guys. They came out with a podcast. It's a nice splash and they'll get some market, but I don't think it is as big as that everyone thinks it's going to be.
Oh, okay.
In a scenario where they are taken over, does that traditionally mean that more chips are going to be produced, or is it more of a buy and shut down sort of thing, like we've seen with many acquisitions in the past, where the incumbent buys the company not really to incorporate it into its core business, but to just take out the competition, and it gets kind of slowly wound down over time?
Yeah, like I said, I think the IP makes sense, and this goes back to what Jensen unveiled at GTC. There's a segmentation on inference. There's like very fast, high-end inference, and then there's like regular speed, and then there's like slow speed, which is like free. So we're going to be in this tiered market where, based on how much money you want to spend and based on the intelligence of the model, you will pay more for faster inference speed. And it just depends on what it is. But the thing is with Etched, because it's literally etched into the chip, whatever the model is, you're kind of stuck with it. So if something changes architecturally, those chips pretty much become obsolete. And you don't have that with like a GPU, because you can modify it or basically change it with the software and CUDA. But with Etched, it's
So you're saying the depreciation risk that the bears have made about NVIDIA's GPUs that has not played out at all, let's be honest, you're saying that actually is a much more serious thing for Etched, because if Anthropic has some genius model and then a few months later they make a leap step in ability, that the Etched, you have to make a new Etched chip. So actually depreciation risk is a very severe thing.
yeah, that's basically it. I mean, that's the way I see it. But then again, if something is mature, like a mature older model, like a Llama or whatever, Mistral, that it's not going to change, and as good as it's going to get, then you put it on Etched and you run the chatbot and you're like, oh wow, this is so fast. This is faster than anything else I ever seen in my life. And then it works, then it makes sense. But you're kind of like, you're pigeonholed in these like very distinct, bespoke segments for fast inference. It's not general purpose.
And so there are
What's the type of, can we theorize about what a task might be? Something that would make sense, where you have clarity on what the task is going to be over a period of time, that would make sense to use a chip like this versus something that has more of a general purpose
Maybe like
structure.
for like law, basically if you have all like the legal history of something uploaded to the LLM or the model, and you pretty much realize that most of the laws aren't going to change and it's pretty static, then you could have this work in a chatbot format where you can quickly ask questions, and instead of like waiting for like Claude or Opus to like think for like a few minutes, you'll get the answer much faster.
Okay. And so what Etched chips have that is similar to Trainium or Google's TPUs is that they are used for inference, not training, matrix multiplication. But the difference that etches is that the transformer code is literally on the chip. What advantages versus disadvantages does that have relative to the other ASICs chips? So Google TPUs and then Amazon's Trainium.
Like I said, if transformer architectures change or evolve, you're stuck with whatever's etched on that chip. So the obsolescence risk is real versus the stuff that I've written about with NVIDIA and their CUDA architecture and what they're doing. Because it's all hardware, software co-designed, you get software improvements over time on the same hardware. The same thing with like a Tesla car, right? You get over-the-air software updates. But if the code is literally etched in the chip, you can't physically change it. It's just there. It's stuck. And that's where you get that risk. So you're hoping that these things don't evolve or get better, but they work faster. So for specific niche use cases, I feel like the etch chip will work well and will be pretty amazing. But the inference market is
How fast does that code change? I mean, what are the examples? What are the times that we've seen this type of new code come out that improves the efficiency and would have obsoleted a chip like this?
I mean, we've seen an evolution over transformer architectures. Things are definitely changing with how things are being computed. You saw that with DeepSeek, with mixture of experts. You're seeing it now with agentic workflows. So things are changing and in flux. Nothing is static, especially in this AI world, as what we've seen is when you run larger training runs with bigger models, you get better output. So it is recursive. Then again, this isn't replacing training, right? This is inference only. One piece of the puzzle, right? Which the whole point with other products, like say for example, AMD or NVIDIA, you train on both of these and then you can basically shift back and use those same chips for inference. So you get dual use instead of single use.
Ben, what do you make of the argument that I've encountered, I'm sure you've encountered, that NVIDIA's moat of CUDA, the fact that all these software engineers are coding on NVIDIA's language and in that ecosystem is so strong, that's a huge advantage for NVIDIA, that moat has been slightly weakened by the fact that you have these new things like PyTorch and JAX, and that the CUDA moat is a little bit weak. What do you make of
Yeah,
that?
I saw people
Weakened,
talking
more
about
weak.
that. There was a video clip of me speaking with Dave Salvatore at Google Cloud Next. I asked him the same question. NVIDIA internally is using Cursor, and there's another startup that they invested in to basically help optimize CUDA kernels with AI. And that's how they build the optimizations. They're using AI themselves. They're not against it. It actually helps. But the thing is, once you have everything flowing together as one with the co-design of the hardware and software as one whole system, that's where you have to look at it. Things, you get improvements on each side, from the networking, from the power, from the heating, from the cooling, from the computing. Everything is CUDA connected. So if you squeeze out a little bit from each part, that's where you get the net benefits and the increase. But if you're just one part of the stack with the custom ASIC, you're not going to be able to control the rest of the stack. That's the whole point of buying everything as one whole system, because you're able to squeeze a little bit from each part. And people, I think, have a hard time to realize that. I think the biggest thing that people are still sleeping on, and I'm going to say this so people really look into it, is NVIDIA Dynamo, how that software that runs on CUDA controls the whole data center from power all the way down to compute, how it's all optimized. These guys are basically squeezing out every single token per watt that they can. It's just pretty amazing. And that's how they get those performance improvements. And it's only on version 1.0. I think that's really the secret sauce. Forget the chips. I mean, everyone's talking about, oh, 4 dies, 2 dies, this memory. The secret sauce of NVIDIA, I've been there many times, is the software. It's a software-driven company that happens to sell a chip. And I think people have a hard time wrapping their head around that. They're just focused on the wires and the cabling and how many capacitors and memory and this and that. The secret sauce is the software, and it's the software developers and engineers all behind it. The hardware enables all that software. That's how everything is driven by software in that company.
Who do you think are NVIDIA's most potent and risky to NVIDIA's competitors in software, whether it's NVIDIA Dynamo running the software or in CUDA? Excuse me, CUDA.
I think the biggest NVIDIA competitor out there is obviously Google and their TPU program. That's bar none from a generational standpoint and a processing standpoint. It's almost on its 8th or 9th generation. They have a mature team. They have a mature supply chain. They have everything running on it. And now obviously they're trying to work with, I believe, Blackstone to create TPU sales, to create their own TPU ecosystem with other companies and FluidStack and all that other stuff. So I think that's the only really credible game in town. Everything else is sort of on Gen 1. Even if you look at OpenAI Jalapeno, it just came out. We'll see how it actually works in the wild. I mean, we don't know. It's one thing to just have a picture of a wafer and hold it up for a photo opportunity and a picture of a chip. It's another thing to actually put it all into a data center and heat loads and powering it up and uptime. I mean, there's a lot of, it takes a lot to just get a data center operational and fully functional. It's just not taping out a chip. I mean, I think people have to realize NVIDIA and other companies, you have to be in the business of selling complete end-to-end systems, not just a discrete chip.
Let's see, of the NVIDIA killers potentials, of the potential NVIDIA killers, so let's see, Cerebras, I'll say Etched. You said the other one, I forget, sorry.
There's Positron, there's
Positron, yeah. And what are the other ones?
I'm sure there's probably, I think Mythic is another semiconductor company that's being like reborn to do like inference. I mean, there's a bunch of companies out there that are trying to do it, but
which do you think had the most promise? That's my question.
I mean, it's hard to say. I mean, like, I would think it's still Google and their TPU. I do think Cerebras, its days as a standalone company will be limited. At some point, there will be some sort of AI winter. They won't survive and they'll get absorbed by either Intel or AMD or Broadcom or something. I just don't see them as standalone. And all these startups in mind, they're being built with having an exit or a buyer in mind. I don't think their exit is IPO. It's going to be really challenging because their margins aren't going to be there. They're not going to have enough money to balance the supply chain. To be in this business at that scale, you need to be in the $1 trillion club. So guys like Elon and SpaceX, they could absorb some of these guys and roll them into their data centers and say, oh, we can plug them right in for faster, cheap inference. No problem. We're going to buy them cheap. It's a rich man's game. And $800 million is still not enough to really play ball with these guys.
And what about AMD? Let's see. Very good semis analyst. Jukon from Citrini has said, I think it's him or someone else in the Citrini semis team, said that here we go. If we could share the screen, say Rubin Ultra won't be able to gain an edge over MI500, which is AMD's chip. And he was quote tweeting a thing from
I saw that. I mean, I don't really
Yeah.
bother myself with the number of dies on a chip and like all this other stuff. Again, the moat is in the software and the ecosystem. You're not gonna like these data centers that are coming out were planned last year based on this year's generation of NVIDIA product. They're not gonna all of a sudden be like, oh, we're not gonna use Vera Rubin Ultra because it's went from 2 die to 1 die, and we're gonna switch, we're gonna cancel all of our POs and buy AMD all of a sudden. It doesn't work like that. And I think a lot of people don't understand like the aspects of actual how business is done. Once you place a purchase order and it's probably non-cancelable, and the way you design that data center based on what GPU is coming out, because NVIDIA does share its roadmap with its customers, like you're skating in that direction. I don't see people all of a sudden swapping out one technology for another. It just doesn't make sense. Maybe they could gain some share. Obviously, like if I was a hyperscaler like Meta or Google or Microsoft, yeah, for diversity in my fleet, I'll order some AMD just in case. But I think my primary workhorse, and from what I've seen from other hyperscalers and customers, has mostly been NVIDIA. I mean, they're winning share across the board because they can ship and deliver on time. They have the supply chain. Remember, AMD is about to ship its first rack scale solution. They don't know it. They've never done this before. It's their first go around. So yeah, everything on paper and looks great and all these charts and these like inference numbers or whatever it is. But the question is like if you're a data center operator and you're like a CoreWeave or Nebius or one of these other companies that maybe went from Bitcoin mining to data center, you're basically borrowing money at 7-8% and you're buying GPUs and you're financing construction to do all this stuff. Are you going to take the risk and try to save a few bucks and buy from AMD or maybe even like Etched and try to experiment to see if it works, or just pay a little bit more and know you're going to get the right product at the right time with support with NVIDIA? I mean, that's a simple business decision. I mean, I would rather pay more knowing that I'm going to get the right product at the right time rather than gamble on some other technology. So you'll see them gaining share in some aspects, but not as much as everyone thinks they will, because it's a business decision at the end of the day. Like you want to work with a company that you know can deliver so you can sleep at night, so you don't get fired from your boss for ordering the wrong product. I mean, all these things work together.
Okay, so Ben, I understand, and I'm not going to dispute or even challenge your point that NVIDIA is going to stay the king because the king has such inherent advantages. But do you challenge the fundamental premise of Jukon's tweet that, again, if we could share the screen, that basically the AMD's chip is really, really good and it could be even better than NVIDIA's chip on the hardware side? Do you challenge
I
that?
don't know. I haven't really paid attention to all the details and the numbers on what it is, but I think things need to get into full production, and then by then you'll probably have a change from whatever the hardware is on NVIDIA or even on the software side, which might even make better improvements. And then all of a sudden, whatever he wrote is moot. I mean, it's too early to make these types of calls because they haven't even shipped their product yet. Like this,
Yeah.
like that's kind of what it is. To make judgment calls like that on paper, theoretically, it makes sense. But are you actually in production? Have you shipped? Have you installed it? Have you energized it? Have you run the models? Like there's a lot that needs to go on with that stuff before you make those types of calls.
Ben, I'll just, because time is limited, I'll throw 3 topics at you, and whatever one you've got the most
It's
to
the
say on,
lightning
just
round?
pick that one. Yeah, well, okay, memory or EDA, so like cadence and synopsis, or, okay, curveball, and if you don't want to talk about it, you don't want to talk about it, Rambus.
Rambus is an interesting name. I covered it a while ago. They're an IP-based company and they have a lot of intellectual property when it comes to the PHYs between HBM memory and the processor. And obviously, EDA companies have some of those, they're called PHYs, PHYs, that they sell also. And they're a royalty-based business. And I think the bull case, which is sort of making a comeback, is with agentic and enterprise-based GPUs that work with CPUs. You'll need more of Rambus on the interconnects between these for the memory, and therefore it gives a tailwind on units sold. And because it's a royalty-based business, they don't actually make a physical product, you'll get an uplift. So you could sort of make the argument that they're like the toll for HBM memory when it comes to these things. So it's almost like a royalty business like ARM, but ARM actually is coming out with its own CPU next year. So it's interesting. It's always hard to understand and value because Rambus doesn't make a physical product, but they have an interesting
They
vision.
are a fabulous designer as well of the, what's it called? The R's, oh man, I forget the acronym, but of the memory clock timer.
Yeah.
Yeah. But yeah, they're not a fab, of course. Yeah.
Yeah,
Yeah.
they basically make money on royalties. Like, here's our design. Are
Yes.
you going to use it in all these chips? Okay, we're going to charge you. So based on royalties, and that's how they make their money.
Jack loves a royalty company. It's his favorite business model.
That's true. I do not own Rambus, but I'm finding it very
Yeah, I checked my
interesting.
Substack. I've wrote about it early in January. I wrote this whole like a bunch of memory pieces. I went pretty deep into the memory. Memory is obviously, it's everything. We have 3 players making it, and I think the recent run up in Astera Labs, Marvell, and Credo goes to the fact that it's called CXL. Like, instead of these companies paying high price for memory, why don't we use older memory, pool it, run connectors to it, share it, and that's why these companies are benefiting, and that's why you've seen a run up recently on Astera. It's like about $500 a share when it was one of the optics losers early on in the year in March, and the same thing of Credo and Marvell as well. So it's just funny because I feel like a lot of investors today don't really understand the space, and they're feeding a lot of these things in the Claude and LLM to really say, oh, is this bad? Is this good? Good, bad, good, bad.
Yeah, yes.
You can't look at it that way. You have to extrapolate and really see why these companies exist and where they're fitting in, and do a little bit more research as opposed to just LLM based stuff.
So use AI less. That's what Ben
No,
said.
I mean, use AI, but go look at the company, go talk to their booth, go see the actual product. Where are you guys selling into? Oh, like I went to the Credo booth at the trade show. It was right after GTC, OFC. It was in Los Angeles. And I said, oh, you guys have no optics? It's like, oh no, we have an optics product, but we're also very busy on copper, and we can use copper when we can. So it's like it's just right there in front of you, but people just choose not to listen. Or a lot of people, unfortunately, like to follow cartoon characters on X that have large followings, that tweet certain stocks. I mean, I don't know. I'm a real person. What I write about, I invest, I put real money behind it. And when I believe in something, I believe in it. And I think that's really what it is. And this is like a cycle that obviously is bringing a lot of attention to this space that's been ignored for the last 20 years because no one wanted to invest in hardware because it was too hard and it was too capital intensive, when you can just invest in some CRM SaaS business, which your only expense was your Amazon Web Service bill and some headcount. And now all that's kind of flipped over its head with AI. So everyone's trying to do hardware and harder stuff. So it's just 20 years lack of investment has caught up. And that's why you see this huge uptick in semiconductor capital equipment and chip stocks and ED. I mean, everything is just mooning because it's been suppressed for so long. There's been a lack of investment. I mean, go look at it.
The EDA is the one thing that's not mooning, Ben, because people say, oh my God, well, AI is so powerful, they can make their own EDA software. And something in the press release of the Jalapeno OpenAI chip said, well, we designed our own software to make the chip. I don't know if that, I doubt, honestly, it means that they didn't use Cadence or Synopsys. But yeah, what do you make of EDA, the one sector in semis that's not booming in terms of stock performance?
I haven't looked in detail, but EDA is something necessary. It's a duopoly between Synopsys and Cadence. It's something China wishes they have. And remember, it's also, these companies have deep libraries of reference designs that you build chips upon. And if you look closely, I believe NVIDIA has a partnership with Synopsys for a lot of these types of things. So to say that...
Yeah, they're a shareholder too, yeah.
To say that, I mean, I think the best example, if you look from a stock perspective, if you look at Claude, in February, they came out with this whole thing about creating software artifacts. And the one company that did software artifacts was JFrog. And the stock crashed to like $20. And now it's gone up back to like an all-time high of $90. So just because one of these big LLM players like Anthropic or OpenAI says they did something doesn't mean it's the end of the world for these types of companies. And I think people conflate that, and They won't invest, and it could create an opportunity for a savvy person to maybe enter into those companies when people think they don't have it, they're moatless, and I don't think they're not. So a company like Synopsys and Cadence are like duopolies. Like you can't find another one out there. And AI
Yeah.
will only improve and make EDA better. It won't make it worse. It will turbocharge the business.
Yeah, well, certainly if you're right, then there's a potential giant opportunity in those two stocks. Ben, your website, your Substack is bepresearch.com. I am a subscriber. I really like it, and we gotta leave it there. Max, I know you've booked some incredible guests for
Thanks,
tomorrow.
guys.
To tell us, yeah. Thanks, Ben.
Thank you, Ben. Oh, we'll bury the lead and we'll leave everybody